Have you ever heard of the Monte Carlo method?
Oh, I mean, if you follow finance or sports betting, you definitely have.
Right. Or even, the algorithms powering modern artificial intelligence. It's everywhere. It's this statistical algorithm used in everything from predicting the stock market to environmental risk assessment.
Absolutely everywhere.
But so what if I told you that this incredibly ubiquitous algorithm, the foundational blueprint for the hydrogen bomb, and the literal birth of chaos theory all sprang from the exact same mind?
Honestly, it sounds like an exaggeration or maybe a composite character from some science fiction novel.
Yeah.
But it is entirely real. We're looking at a singular individual whose work kind of bridges the gap between pure abstract thought and the raw, world-altering realities of the 20th century.
Well, welcome to today's deep dive. We've got a fantastic biographical text as our source material today. And our mission is to trace how a pure mathematician from Poland named Stanislaw Ulam became this unsung architect of the modern world.
It's quite a journey.
It really is.
Yeah.
We're going to explore how he translated, abstract numbers into the terrifying power of the atomic age and ultimately the dawn of the digital era.
Okay, let's unpack this because it is just astonishing to see how one single person could be intimately involved in so many massive historical breakthroughs.
What's truly fascinating here is that his genius wasn't just in solving difficult math problems. I mean, there were plenty of brilliant mathematicians in his era.
Right, he wasn't the only genius around.
Exactly. His unique contribution was recognizing how a brand new invention, the electronic computer, would fundamentally change how we solve problems. He realized computers weren't just fast calculators. They were a completely new way to interact with reality.
Wow.
But to understand how he arrived at that conclusion, we really need to understand the intellectual paradise where his mind was formed.
And that paradise was Low Poland, which is now Lviv, Ukraine. So he was born in 1909 into a wealthy Polish Jewish family, and he becomes a central figure in the legendary Welsh School of Mathematics.
A very unique environment. Really unique. Picture this. You have these brilliant minds gathering for hours, not in a stuffy university lab, but at this lively place called the Scottish Cafe.
Right, just drinking coffee.
Yeah, sitting at these marble cafe tables, drinking coffee, and furiously writing complex mathematical proofs in a thick notebook they called the Scottish Book, which, fun fact, was actually provided by the wife of another famous mathematician, Stefan Banach.
And Ulam was just an absolute powerhouse in this environment. Out of the 193 problems recorded in that notebook between 1935 and 1941, he contributed 40 of them as a single author.
Wait, 40? Just by himself?
Just by himself, and another 26 in collaboration with others.
Yeah.
He was totally immersed in pure mathematics.
Stuff like topology, right?
Yes, topology, which is the study of spaces that can stretch and bend without breaking, or set theory, looking at fundamental collections of objects, and ergodic theory, examining how complex systems behave over long periods.
Right.
He was doing mathematics for the sheer intellectual beauty of it.
It's like I'm imagining someone essentially solving the deepest puzzles of the universe just for the thrill of the game.
That's a great way to put it.
But, that kind of insulated, beautiful world was entirely fragile. In 1935, he meets John von Neumann, who invites him to the Institute for Advanced Study in Princeton. So he starts splitting his time between the U.S. and Poland.
And then the timeline takes a really dark turn.
It does. On August 20, 1939, literally just 11 days before the German invasion of Poland, Ulam and his 17-year-old brother Adam board a ship for the U.S. And, terribly, the rest of his family, his parents, his sister, they perished in the Holocaust.
Which is just, it's hard to fathom. That brutal shift from abstract beauty to unforgiving reality didn't just change his geographical location, right? It profoundly reshaped his worldview.
I can only imagine.
He later described himself as an agnostic. In his own words, he said that when he was almost close to the idea of God, he felt immediately estranged by the horrors of this world, which he seems to tolerate.
Man, that is heavy.
It is. He was thrust into this brutal reality where abstract puzzles at a cafe table were no longer enough. Practically speaking, in America, he needed a way to survive. He needed a war job.
Which leads to this crazy story. He gets a mysterious invitation from a physicist named Hans Bethe to join a secret project somewhere in New Mexico. And he actually figures out where he's going by doing a bit of brilliant detective work.
The library card story.
Yes. He goes to the university library, borrows a New Mexico guidebook, and just checks the checkout card in the back. He sees the names of his Wisconsin colleagues, like Joan Hinton, David Frischpeople, who had all mysteriously vanished from the campus.
Right, just gone.
And he realizes immediately, oh, they're all gathered at this secret facility.
And that facility was the Los Alamos Laboratory, the beating heart of the Manhattan Project. So Ulam stepped right into the U.S. wartime effort to create the atomic bomb.
And almost immediately, the project hit a massive wall, right? The implosion crisis of 1944.
Exactly. The initial plan for the plutonium bomb was a gun-type design. The idea was to basically shoot one piece of nuclear material into another piece to create a critical mass.
But that didn't work.
No, they discovered the plutonium they were producing in reactors was too reactive. It would detonate prematurely and just fizzle out. So they had to pivot entirely to a design that would compress a solid sphere of plutonium using perfectly timed explosive lenses.
And under the enormous pressures of an explosive implosion, those solid metals don't act like solids anymore, do they?
Not at all. They start behaving like fluids. So Ulam and von Neumann were tasked with these incredibly complex hydrodynamical calculations to ensure the explosive lenses would compress the plutonium sphere perfectly evenly from all sides.
Because if it's not perfectly symmetrical,
If it's even slightly asymmetrical, the plutonium would just squirt out the sides and the bomb would fail completely.
I'm really struggling to picture this transition. I mean, you have a guy who spent his career studying continuous spaces and elegant, pure mathematical theories. Isn't doing the messy math of fluid dynamics and explosives like the exact opposite of what an elegant, pure mathematician wants to do?
Oh, completely.
Otto Frisch even joked that Ulam was a pure mathematician who had sunk so low that his papers now contain numbers with actual decimal points in them.
Which is a great line, but if we connect this to the bigger picture, it was a massive philosophical shift for him. Ulam realized that elegant, pristine formulas were totally useless when dealing with the chaotic reality of fluid dynamics and explosives.
Right, reality is messy.
Very messy. He noted that he had to stress pure pragmatism. He championed what he called a heuristic survey of the problem. He wasn't looking for a perfect equation anymore. He was looking for a rough, practical map of the physics using, quote, simple-minded brute force.
But wait. Doing things by brute force manually,
Huh?
with dozens of human computers crunching numbers on mechanical calculators, that sounds agonizingly tedious.
Oh, it was a nightmare. It was so tedious. But his willingness to abandon mathematical elegance for practical results was the exact mindset needed to recognize the potential of early computers. Doing things by brute force manually is terrible, but doing things by brute force with a machine, that changes human history.
And that specific realization actually comes out of a terrifying personal crisis for him, doesn't it?
It does. In 1946, the war is over, and Ulam suffers a severe attack of encephalitis. He requires emergency brain surgery.
Wow.
Yeah, and during his recovery, he temporarily loses the ability to speak. He's absolutely terrified that he has lost his mental faculties. I mean, for a mathematician of his caliber, your brain is your entire identity.
Losing that must have been a living nightmare.
Truly. His friend, the legendary mathematician Paul Erdős, came to visit him during his recovery. Erdős sat with him, played some games, and reassured him, saying, "Stan, you are just like before."
That's so sweet.
But the physical recovery was still incredibly slow, leaving him with a lot of idle time.
So to pass the time, he plays endless games of solitaire. And because his brain is wired the way it is, he tries to calculate the exact probability of winning a game before he even deals the cards.
Naturally.
But he hits a wall. He tries to use combinatorics, the complex math of counting and arranging variables, but there are just too many possible shuffles, too many branching pathways. The math is too messy for a single equation. And then he has this absolute epiphany.
Yes, he realizes that instead of trying to write one perfect, godlike equation, he could approach it entirely differently. What if he just played 100 games and counted how many he won?
Right.
The ratio of wins to losses gives a highly accurate statistical estimate of the probability.
Here's where it gets really interesting for me. It's kind of like trying to calculate the exact volume of an irregular, jagged lake using pure geometry. It's nearly impossible because all the curves.
Right.
But what if you fire 1,000,000 cannonballs randomly into a square area around the lake and just count how many splash into the water versus how many hit the dirt? That ratio gives you the exact area without ever needing to measure a single curve. That's essentially what he figured out.
That is a perfect analogy. But obviously, humans can't manually play enough games of solitaire or fire enough cannonballs to get an accurate estimate in a reasonable time.
Sure.
But Ulam had been working with the ENIS, the first general-purpose electronic computer. He realized a machine could play thousands of virtual games of solitaire in seconds. He shared this with John von Neumann, who immediately saw the potential for applying this to the physics problems they were struggling with.
And they named it the Monte Carlo method, right?
Yeah.
After his uncle Miku, who frequently traveled to the casinos in Monte Carlo to gamble.
Exactly. And it is hard to overstate the paradigm shift here. Before Ulam, computers were mostly seen as giant calculators for fixed equations. You punch in numbers, you get an exact answer. Ulam realized they could simulate random reality. Enrico Fermi loved this so much, he literally built an analog computer, the Fermiac, just to do it. It was this mechanical trolley he'd roll across blueprints to physically simulate neutron diffusion using the Monte Carlo method.
That is incredible.
Yeah.
But the reality of the Cold War was about to pull Ulam right back into weapons development.
Unfortunately, yes.
In August 1949, the Soviet Union tested its first fission bomb, the RDS-1. So the U.S. nuclear monopoly is over. In response, the U.S. government starts a crash program to develop a fusion weapon, the hydrogen bomb, or the super.
And Edward Teller had been pushing for a fusion bomb for years. He had a design for the super that basically involved placing a massive amount of fusion fuel near a standard fission bomb. The theory was the heat from the fission explosion would ignite a self-sustaining fusion reaction.
But Ulam was highly skeptical of Teller's math. He and his wife, Françoise, who, by the way, was working as a human computer doing these laborious calculations, started running the numbers.
Using his Monte Carlo method.
Exactly. He mathematically proved that Teller's design was completely unworkable. The fusion reaction wouldn't sustain itself at those densities. It would just bleed off energy and fizzle out.
This raises an important question about the human element here. The tension at Los Alamos was immense. The fate of the Cold War supposedly hangs in the balance, and Ulam just proved the lead designer's pet project is a dud.
Awkward.
Very. But Ulam didn't just break Teller's design, he figured out how to fix it. In January 1951, he had a breakthrough. What if you use the mechanical shock from a primary fission explosion to physically compress the fusion fuel before it ignites?
Just squeeze it to extreme densities first.
Yes, then the fusion reaction could actually sustain itself.
So he brings this to Teller, and Teller almost immediately realizes it's the missing piece, but he adds his own crucial insight. Teller realizes that radiations, specifically soft X-rays from the primary explosion, would travel way faster than the mechanical shock wave.
The physics of that is brilliant and terrifying. Teller realized those soft X-rays would flood the inside of the bomb casing, instantly turning the outer layer of the fusion container into a superheated plasma.
And as that plasma explodes outward, it drives a massive shock wave inward.
Exactly, compressing the fusion fuel to incredible densities just before ignition.
So together, they submit a joint report in March 1951. This concept became known as the Teller-Ulam design. It became the blueprint for virtually every thermonuclear weapon on the planet. And when they tested it in 1952, Ivy Mike, the explosion was so immense it completely vaporized the island it was sitting on.
It's staggering. And, science requires massive collaboration, yet ego still plays a huge role. After the test, Teller aggressively tried to downplay Ulam's role, trying to claim primary credit.
Wow, really?
Yeah. Von Spathe famously observed this and said, Ulam is the father because he provided the seed, and Teller is the mother because he remained with the child. As for me, I guess I am the midwife.
That's a great quote. But so what does this all mean? I have to ask on behalf of everyone listening. Did Ulam actually want to build a doomsday device? How did a man who lost his family to war rationalize this?
It's a profound paradox. To keep it strictly to the historical record, his wife Françoise offered some insight. She recalled that Ulam would reassure her that, barring accidents, the sheer destructive scale of the H-bomb rendered nuclear war impossible.
He viewed it as the ultimate deterrent.
Right, a deterrent so terrifying it would force a tense peace.
Okay, wow. Well, moving beyond weapons, his mind was too restless to just stay on bombs. As the 50s rolled on, he applied his computational mindset to entirely different frontiers.
Chaos, space, biology.
Let's start with chaos. The famous FPUT problem with Enrico Fermi, John Pasta, and Mary Singo. They used the MANIAC computer to simulate a vibrating string of masses held together by springs.
But not normal springs. They programmed nonlinear springs, meaning the force changed unpredictably the further it stretched. According to classical physics, the energy should gradually distribute itself equally among all the vibrational modes.
The equipartition of energy. They fully expected it to just eventually settle into messy thermal noise.
Right. They set it running, and at first the energy mixed as expected. But then magically, almost all the energy periodically returned to the exact original starting mode.
Wait, really? That's like watching a shattered glass perfectly reassemble itself on the floor over and over again.
It completely defied traditional physics. They discovered this by accident while playing with a simulation. It birthed the fields of nonlinear science and chaos theory. It was later explained by things called solitons.
Self-reinforcing wave packets, right?
Exactly. But the key takeaway is that Ulam used the computer to conduct an experiment in pure mathematics, observing phenomena human brains alone could never calculate.
Like a telescope for math. And speaking of space, I was reading about Project Orion, and I was floored. Wait, let me get this straight. He and C.J. Everett seriously proposed propelling rockets into deep space by dropping small nuclear explosions out the back of the ship and riding the shockwave.
Yes.
That sounds like science fiction. Why wouldn't the ship just vaporize?
It sounds like madness, I know, but the engineering was heavily studied. The design included a massive pusher plate at the bottom, coated with oil, connected by colossal shock absorbers.
To smooth out the jolts?
Right. Ulam believed the future of mankind was, quote, inexorably now with going outside the globe. Nuclear propulsion was the only viable way he saw to explore the solar system. The project only ended because the 1963 Test Ban Treaty made detonating nukes in space illegal.
That is just wild. And then, from the solar system, he turns inward to the code of life. At the University of Colorado, he pioneered biomathematics.
Think about a nuclear chain reaction. A single neutron strikes an atom, branching out exponentially. Ulam realized that mathematical branching process look exactly like a single genetic mutation branching out through an evolutionary family tree.
Oh, wow.
He applied the Monte Carlo method to map evolutionary pathways and genetic distances in DNA long before the human genome was sequenced.
So whether he was looking at cosmic rays, DNA, chaotic systems, or Solitaire, his core belief was that computers allowed us to experiment with math, just like a chemist experiments with chemicals.
Exactly. Mix variables in a machine, observe the reaction, and discover hidden truths. He was the bridge from solitary geniuses writing proofs in cafes to the modern world of massive, data-driven simulations.
So summarizing this incredible journey, we've traced a man who escaped the Holocaust, applied his mind to the Manhattan Project, gave us the H-bomb blueprint, invented the Monte Carlo method, and laid foundations for chaos theory and computational biology.
His legacy is woven into almost every aspect of modern science.
Which leaves us with one final, mind-expanding nugget. In 1958, Ulam recounted a conversation with von Neumann where they noticed the accelerating progress of technology. Ulam actually coined a term for this. He said, "We were approaching an essential singularity in the history of the race."
Predicting a technological tipping point over 60 years ago.
Yeah. So for everyone listening, take a moment to look around today. Look at the AI generating art, the algorithms running markets, the massive climate simulations. Almost all of it relies on the computational foundations Ulam laid. Ask yourself, are we living in the singularity that Stanislaw Ulam predicted? It all started with a brilliant mathematician who realized that sometimes, to understand the universe, you just have to roll the dice. Thank you for joining us on this deep dive. Keep exploring, keep questioning, and we'll see you next time.